Hello and welcome back. This is Greg French. Today we're going to look at Subnet Mask. Subnet Mask is used in the network for a computer or router to determine the IP address portion that is for the network and the portion of the IP address that is for the node or host. Each IP address is unique and each computer has to have a unique IP address, but a portion of the IP address is going to be reserved for the network and the other portion is for the node. It's just like in a neighborhood. You've got a street address and a house address. That street address is for everybody in that neighborhood or on that street, and then your house address is going to be like a node address or a host address. Each one has to have a different or unique one. So the network portion of your IP address would be like a street name, and the house number would be like the host or node portion. Hopefully, as we continue through this, you'll get a little bit better understanding of what a subnet mask is, and it won't be as difficult. The key to it is going to be understanding binary numbers. So let's get started here. Here's just kind of a simple illustration of two work groups within a company. These work groups are separated using routers to separate these work groups or their broadcast domains. And if you notice up here, I've got some IP addresses assigned. I've got zeros on 3 of them. That 0 is normally indicating a network address. We usually reserve the 0. We don't assign it to a computer, so the 0 would be used to represent or identify a network. So we've got 3 networks up here, and these are going to be what we call subnets. Now 2 of them are going to be assigned to these 2 work groups. Down here you see some more IP addresses, but here we've got the number 1 assigned to this individual and the number 2 assigned to this individual here. The network address is the 135.68.2. The IP node portion or host portion is 1 for this individual and 2 for this individual. Over here we have a different subnet or a different network address. It's 135.68.3. .0 indicates the network. Down here the 1 and the 2 represent the IP address assigned to these individual users. Up here we've got a connection to our internet. So our default gateways, we would have 1 for this subnet here, 1 for the subnet here, and then these 2 routers would have a default gateway going up to the network. So this is just a simple illustration, so hopefully this will help. Let's continue on. Subnet mask. The default subnet masks for class A, B, and C are represented here. For class A, it's 255.0.0.0. For class B, we have these 2 octets set at 255.255, and then the last 2 are 0. The class C, the first 3 here are set to 255, and the last one is 0. Now 255 represents 8 bits. An IP address consists of 32 bits, and those 32 bits are separated by 8-bit octets, and we have dots in between them. So to this table down here shows the 8 bits and then the values assigned to them. The first one is a 1. That's a base 2 system, so these values double as you go from right to left. So 1, 2, 4, 8, 16, 32, 64, and 128. So 128 is the highest value within an 8-bit octet, and the number 1 is the first one. If we set all of these high, I do that by representing, instead of a 0, I represent it with a 1. And then we add these all together, we get 255 as our largest binary number that could be represented by 8 bits. If you need some review on the binary numbering system, I do have a video for the binary conversion from binary to decimal and decimal back to binary. It might be good to review that, because understanding binary numbers is going to be the key to understanding the subnet mask and networking within a network. Next here I have an IP address. This is 135.68.1.1. This was the network address that was used in that first illustration. Now I've represented this IP address down here by binary numbers. These binary numbers, again, we look at each octet here as just 8 bits. So the first octet, 135, can be represented by setting the 128-bit high and then also setting the 4, 2, and 1. So 128 and 4 is 132. And we add 2 more for 134, and we add 1 more for 135. So by setting the 128, the 4, 2, and 1, and not the 64, 32, 16, or 8, we are representing 135 as the binary number for the decimal equivalent, 135. Now the next one is 68. So if we look down the second row here, you'll see that 64 was set and the 4 was set, nothing else. So 64 and 4 is 68, and that is representative in binary to the number 68 in decimal. The last two are pretty simple, just 1 and 1, so we don't set anything but the first bit, the 1 bit, on both of those last two octets. So again, you can see that binary and decimal conversion is very important for determining an IP address as we convert it from decimal to binary. And this is going to be, again, a key for understanding the subnet mask, and I'll show you right here. IP address 135.168.1.1, we said was a class B. If you remember on that first slide or the second slide, we showed that the class B subnet mask or default subnet mask was 255.0.0. Now down here I've changed that subnet mask to 255.255.255. So I've changed this octet from zeros to all ones. By doing that, I've created a subnet within this class B range. So I've taken this octet and I've now reserved it for the network portion, because these first 3 octets are what we call the network portion of this IP address. The last octet is what we're using to assign nodes or hosts. We can put a maximum of 254 users in each one of these networks. And again, if we didn't subnet this, we would have 2 octets that we could assign to users, and these 2 octets would have a maximum of 65,000 users. That would be way too many users for a typical network or subnet. We would have chaos just from the broadcasts that were being emitted by the different devices. So in order to get this network to function better, we subnet it, and we subnet it by removing a lot of these users or dividing them into what we call logical workgroups. In the logical workgroups, the network is going to perform a lot better. The last row here of these binary numbers is the result of a Boolean AND function of the first 2. If you remember back in the Boolean algebra, we use AND and OR functions. In the AND function, if we AND 2 ones together, we get a 1. But if we AND a 1 and a 0, we get a 0. So they both have to be set with 1 before we get a 1. And to get a 0, either can be 0 or one of them could be 0 and the other one would be a 1. So to get a 1, you have to have both set 1, and to get a 0, we need a 0 in one of these. And if you follow this along, we've got 1 and 1, so we bring down a 1. We have zeros here, so they all become zeros. So we've got 3 more 1s, so those come down. 0, 1, and then another 1 here. And then the last one here, we get a 1. Now, in this one, we didn't bring the 1 down because within our subnet mask, we've got zeros all set. So these zeros prevent any of these 1s from coming down. Now, this will show to the computer or to the router that our network address only consists of these 3 octets here. The last octet has been reserved for the user or host or node addresses. And this is the key to the subnet mask. The subnet mask is used like a filter within the PC or the router to separate the network portion of that IP address from that host or user portion. This allows the computer and the routers to understand that this portion of the IP address or network portion is what's going to allow the router to route those IP addresses to their appropriate destination. And then once those are received, this IP user portion is used for the individual devices within that network for routing. Let's go back to this diagram here. Hopefully this makes a little more sense now. We've got, again, 3 subnets. They're identified with that 0 in that last octet. We have IP addresses down here assigned to the individual users or devices in that subnet. and the same over here. And then these all come together but into these routers, and then the router routes them into the internet. Hopefully this has helped a little bit to understand what a subnet mask is used for and the importance of it for breaking these IP addresses into the appropriate network portion and the appropriate host or node portion. So again, you might need to review the binary numbering system for a conversion from decimal back to binary. But once you see that subnet mask, the 255 is all zeros, the subnet mask becomes a lot easier to understand. And you also understand the importance of it for being able to break an IP address down into its network portion and its host portion. Hopefully this has helped. I want to thank you very much for your time. See you next time.